Okay, notice not to do these things here. If I have a plus b and I square it, it is not okay to say a squared plus b squared. That is not the same thing. Okay, just doing what we normally do, you can see how you would get this. Okay, you can see that if we do have a plus b squared, we get a middle term. That's the killer right there. We get a middle term. And same thing if we're saying a minus b squared, we get a middle term. We can't just write the a squared and the b squared part. We have a middle term. Okay, don't forget we have a middle term. The cube of the binomial. Okay, so that's something we can do. And instead of going through the pain of doing it like I did, if it's the same thing every time, a plus b cubed looks like this: a plus b times a plus b times a plus b. And then instead of doing the first two and then taking that and doing the third one like we just did in the last example, we could just learn this rule. Notice that when it's plus, everything is plus. Okay? If you notice that. When it's negative, it's kind of interesting that every other one is negative. Every other one. It starts positive, then it goes, positive, negative, positive, negative. So that's interesting. I can see how that'd be useful. And the a squared comes first. So do we have to know the cube of binomial? No, we can do it with what we already know. But it might be nice, might save ourselves a little trouble and time. Okay, so let's look at this. Factor the polynomial completely. You can see that they took an x out front first. Okay, and then hey, what's left inside could be factored, and they factored it. This they factored some more. So the idea is to completely. Not only did we take the x out front, but we also factored the rest of it. Okay, so that's the complete idea. And hey, we recognize from up above, I suppose, you might recognize what we just looked at. That's the difference of two squares. We know that that's going to factor out. These are conjugates of each other, x plus 3, x minus 3. We use conjugates when we get rid of a radical on the bottom of a fraction. We use conjugates when we get rid of an I on the bottom. If you remember back a little bit, we did that. So let's go ahead. Let's see. We can also factor by grouping. They noticed that there's an r in both of these terms, so they took the r out. Okay. And they noticed that there was an s in both of these terms, and they took the s out. This is extremely like our ACB factoring thing, only it's already set up like that when we get here. So if you know how to factor ACB method, well, you know how to do this already. So we have a couple of example problems to show both of these things. You notice here, what's the greatest common factor that I could take out of all three? So I know I make you do these things and you think, why? Well, this is why. So we're going to take a 9 and an m to the third out of each one. So what's left behind? There's a 6m squared. And what's left behind from the 18? There's a 2 and there's 1m left over. And the 9's gone, and so it's just 1. Okay, can I factor this? I could use the ACB method. So I could say, 6 times 1 is equal to 6. Factors of 6 that add up to 2. That's not going to give me 2. And that's not going to give me 2. That's not going to give me 2. No and no. So I'm kind of thinking, I don't think there's any such thing that does this. There's no way this is going to happen for me. So what I would say is I can't factor that middle portion. I tried. I could use the quadratic, but you know what I'm going to get if I use the quadratic? I'm going to get 2 imaginary roots. So I could go ahead and do it. I guess we could do the discriminant. Why not use the discriminant? Let's go ahead and use the discriminant. B squared, so that's 2, so that's 4, minus 4 times A, which is 6, times C, which is 1. Can you see that that's going to be negative? The discriminant's going to be negative, so those aren't real roots. So it doesn't take me very long to use the discriminant to find out that 4 minus 24 is going to be minus 20. And that means no real roots. So I'm done. I thought maybe I could factor the inside, but that's not going to happen. There's no real roots, so that means I can't factor the inside. Okay, so I look at the second one, and I say, you know what's common about both of these? There's a y squared in both of those. This is grouping. I'm doing this by grouping. It's reminiscent. Can I spell reminiscent? Reminiscent of ACB. Okay? So let's see, I factor out the y squared, and I get y minus 7 left behind. And then I notice, hey, you know what? There's a 4 in both of those, so I'm going to say plus 4. And I factor out the 4, and I get, oh, look at that. It's the same thing. I get y minus 7. And then what's my leftovers? My leftovers are y squared and 4, so I get y squared plus 4. And if that was the difference, of 2 squares, then I would factor it. If it was y squared minus 4, I'd factor that again. But it's not. And so I can't factor it. If it's the sum of 2 squares, I'm out of luck. There's no way to factor that. You can try. You can try to factor it. But it's not going to happen. And so I'm done. And again, you could use the discriminant just to see. You say, I think I could factor that. Okay, well, B is 0. And A is 1. And C is 4, and you're like, oh, that's a negative 16. There are no real roots, so you can't factor that. You can't factor that y squared plus 4. So we're done. Did it say solved? Did it say solved? No, it just said factor. So I don't have to tell you what m equals. Up here on the first one, m would equal 0. When m is equal to 0, the whole thing's 0. The inside, there's no answer for that. Here, it'd be y equals 7. And there's no answer for the red portion, because I can't factor that, so there's no answer for that. So it'd just be y equals 7 would make that whole thing 0. If I were solving, but I'm not.